Alright, in this video I'm going to show you an example of putting all three objectives together. So I'm going to find x-intercepts with multiplicity, go from the x-intercept root form to a factored form, and from there be able to tell a few different pieces about the polynomial itself, and then also find the average rate of change. And so for this example, I would be given this polynomial function on the right, the graph of this. So if given a graph of a polynomial function, I should be able to do what's on the left. So the first part, part A, is x-intercepts with multiplicity. So again, to find the x-intercepts, I have to look at the polynomial graph, pictured at right, and identify where the graph hits or interacts with the x-axis. And the x-axis is the horizontal axis. I see that it hits the x-axis here and here, two places, and in two different ways. The first way, at -3, it bounces. And from the previous video you just watched, you should know that if it bounces, it means that the multiplicity is going to be even. And in this case, we're going to use a multiplicity of 2. Over here, it goes through. So if it goes through, that should tell you that it is odd. And for this purpose, we're going to use the multiplicity of 1. So odd multiplicity of 1. And so it's two different situations that are occurring for the x-intercepts that exist in this graph. So I'm going to write x equals -3 with a multiplicity of 2. And then comma, it also equals 5 with a multiplicity of 1. And so at this point, I am done with step A. I've identified all of the places that this graph hits the x-axis and what type of multiplicity it has based off of whether it bounces or goes through the x-axis. From there, I can find the factored form based off of the solutions I just found. And so y equals, the first factor, is based off of my x equals -3. So I know that it's going to be x plus 3 because the sign switches to switch from root to factored form. And then this multiplicity of 2 means that this is going to have a power of 2. Same thing. The solution -3 shows up twice, or exists twice in this polynomial function, so its factor, x plus 3, exists twice as well. And then the next factor is, or the next root is 5, so I know it's a positive 5, so it has to be x minus 5 in factored form. And in this case, it's a multiplicity of 1, so that it's raised to the power of 1. So at this point, I am almost done writing in factored form. I have to consider, is this graph positive or negative? Or is this, the graph positive or negative, or is the function itself positive or negative? And I determine that based off of the tail, or the rightmost point, because you read a graph left to right, and so what is the end doing? What is the end of the graph doing? This graph is going down. It's ending going down, so if it's ending going down, it's going to be a negative polynomial. So that's the first thing. I found the end behavior. It's ending going down, so I know that it's negative. Now I need to find what the highest power of this polynomial is going to be. So I do that by adding up all of the powers that exist. And in this case, 2 plus 1 is going to be x to the third. So the highest power of this polynomial function is x to the third. So another way to say that the degree of this polynomial function is 3, x to the third. And so that also tells me then the final piece of information that I have to include, that it's going to be odd. And all that means, and you can see this pictured here, odd polynomial functions have opposite endpoints. So down here, the rightmost endpoint is going down, and the leftmost endpoint is going up. So that means that it's odd as well from the picture. So you can tell that in two ways. If the power itself is odd, I know it's odd, or if the endpoints are going in opposite directions, I know that it's odd. Now, if the power was even, or if the endpoints were going in the same direction, then it would be even. And finally, the last piece is average rate of change. And we've talked about average rate of change before, but you're going to see this for the rest of Algebra 2, so I need to go through it a little bit more and just, it differs a little bit based off of the information that it gives you. In this case, I have to use the average rate of change formula, which is just the change in y's over the change in x's, and I can show that a little differently, meaning y2 minus y1 over x2 minus x1. So in this case, I have to identify two different plotted points. And they want the average rate of change, if I was analyzing what they were asking me, the average rate of change between the y-intercept and x equals 5. So the y-intercept, again, is where the polynomial function intercepts with the y-axis, and that is right here. And so that coordinate point, or that plotted point, again, the x value at the y-intercept is 0, and its comma goes up to 90. So that is my first plotted point. So they want to know between 0 and 90, and I need to identify that this is my x1, my first x value, this is my y1, my first y value. And then they want, the other piece of information is the average rate of change at x equals 5. So at x equals 5, right here, at x equals 5, so the next y, or the x value is 5, so that's my x2. And at x equals 5, the y value at that point is 0 because it's hitting at the x-axis. So the y value is 0, and that is my y2. So I've identified, for average rate of change, I've identified my y2, y1, x2, x1, and now I just input the information into the formula. So I'm going to rewrite that, or rewrite the formula. So I have y2, which is 0, minus y1, which is 90, over x2, which is 5, and x1, or 5 minus my x1, which is 0. So again, this was y2, y1, x2, x1. I just replaced them with the numbers I found. So 0 minus 90 is a negative 90. And 5 minus 0 is 5. Gives me a fraction. And negative 90 divided by 5 in this case is negative 18. So my average rate of change from that interval between the y-intercept and x equals 5 is negative 18. Now at this point, your answer might look differently. Sometimes it might be a fraction. Other times it would be a whole number. It just depends on what this looks like. So go ahead and try your example. And please pause the video at this point and try all of what I just did. And then when you are done, please check your work with mine. At this point, you should have paused the video and tried your example, the you-do problem, on your own, A, B, and C. A, I have found the x-intercepts with multiplicity here. B, I put them into factored form. And I didn't include this yet, but I know that it has a highest power of 1 plus 1 plus 2 is 4, so x raised to the 4th. And that tells me then, because the highest power is even, that this is an even polynomial. I could have also looked at the endpoints here. They're both going up, and if they're doing the same thing, that means that they're even. If they're doing opposite things, that means that they're odd. If one's going up and one's going down, that means that it's odd. In this case, it's even. And then finally, the rightmost point, the last point, the tail or the end of the polynomial is going up. That means that it is a positive polynomial. So I don't need to write plus here. I just don't have to put minus, and that indicates that this is a positive function. And then finally, my average rate of change. I've identified my y-intercept here, and I've identified the points at x equals 2. I've come up with my y2, y1, x2, x1. I've input it into the formula. I've done the math here, and finally I arrive at this answer. So, if your work, or if you've gotten something different than what I've gotten in this problem, please raise your hand so I can come check your work.